my voice clear to you all? Dear, my voice is clear? Dear, hello, hello. Now is it clear? Hello. Is it clear to you all? Hello. Can you hear me properly? Hello, Priya, Chintan. Hello. 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 Now my voice is clear, everyone? Hello. Priyank, Priyank, can you hear me? Excellent, Priyank. Hello, can you hear me? Hello. सही है चलो तो बंद करता है जो डिस्टर्ब ना है Okay, let me present my screen to you all. Now my voice is clear to you all. Hello. Okay. Okay, so listen, today's topic is elliptic curve crypto system. So up till now you have learned this RSA algorithm crypto system, right? Algorithm and RSA asymmetric crypto system. So what is this elliptic curve crypto system? So today I will explain you that thing. Just wait. So see, although the RSA and algorithm are a symmetric key crypto system, the security comes with a price. They are large key, right? So the researchers have looked for an alternative that give a same level of security with a smaller key size. So and one of the alternative is ECC, that is the elliptical curve cryptography, which is based on the theory of elliptic curves. So, listen everyone, the RSA algorithm is secure when the key size is very large, but the ECC gives a same level of security but with a lesser key size. Okay, so here you can say that the processing of bits makes things simpler in terms of processing power required. So here you can say that in RSA, the key size, that is, if the key size is approximate the 7,000 bits, so in the case of ECC, you can say that it is approximate the 386 bits can provide the same level of security as the RSA with the 7,000 bits, right? The RSA is more time consuming while the ECC is a less time consuming. And in the case of RSA, the plain text and ciphertext, which represent the numbers, while in the case of this ECC, the points in a two-dimensional array. So again, I repeat everyone. So when this elliptic curve crypto system comes in picture, so the RSA is secure when the key size is very large, while the ECC gives a same level of security but with a lesser key size. So for example, what I have explained, if the key size is 7,000 bits, right, in the case of say RSA, so in the case of ECC, means elliptic curve crypto system, it can provide a same level of security as the RSA with the 7,000 bits. So in the case of ECC, it's a 386 bits. Okay, so that can provide the same level of security at the RSA with the 7,000 bits. The RSA is a more time consuming, while the ECC, elliptic curve cryptography, so it's a less time consuming. In the case of this RSA algorithm, the plain text and ciphertext are numbers, while in the case of ECC, you can say that the points in a two-dimensional array, the points are used, right? Now, see, in ECC, what happened? Whatever the data is there, there is some algorithm by using that the particular data is converted to the points, and thereafter you can say that with some key and with the help of the algorithm it is encrypted. Same way you can say that in decryption side also some decryption algorithm is also needed, right? So whatever the data is there in the ECC, first of all it is for particular data it is converted to a points. Okay, so this thing that you have to keep in mind in ECC, whatever the data is given by using some algorithm, right? First of all, it is converted to some points you are getting on the what elliptic curve, some points on the elliptic curve that you are getting. So that you have to remember that. Now, see here the equation. The elliptic curve over a real number that use a special class of elliptic curve of the form. So see, the elliptic curve of the form with this type of form is there, that is y square that is equals to x cube plus ax plus b. Okay, so this is the elliptic curve of the form. So Bhavin, is there any doubt? Hello, Bhavin, can you hear me? Hello, Bhavin, is there any doubt? Can you hear me, Bhavin? Hello, hello, Bhavin, can you hear me? Is there any doubt? Hello, hello, Bhavin, is there any doubt? Okay, no problem. Okay, so listen everyone, the elliptic curve over the real number that use a special class of elliptic curve of the form y square that is equals to x cube plus ax plus b. Okay, so now here you can see that see these are the normally the elliptic curve of this type of form y square that is equals to x cube plus ax plus b. And elliptic curve are of two types. One is a GF that is stands for Galois field that we will see in detail. Later we will see Galois field. Okay, so Galois field that's Muldang sir will explain you about this Galois field. So right now I will not discuss in detail. So there are two types of the elliptic curve. One is a Galois field over a prime number, and another is a over a 2 raised to n. So the prime number is very important for us right now. Okay, so now see here, this is the equation y square equals to x cube minus 4x. Okay, so if y equals to 0, then what happened? X cube minus 4x that is equals to 0. So instead of this, can you write in this way x in bracket x square minus 4? And all of you know, instead of this x square minus 4, what can I write? X minus 2, x plus 2, right? That's why what I get, x equals to 0, x equals to 2, and x equals to minus 2. So that's why which points that I am getting on a curve. So 0, y is 0, and x is 0. So 0, 0, this one point I am getting, 0, 2, and 0, minus 2, right? So these are the points that I am getting on a curvature. So listen everyone, normally in ECC elliptic curve crypto system what happened? Up till now what we have learned in RSA the plain text and ciphertext that are in the numbers, right? But now in ECC whatever the data is given to you, first of all you have to find the points, right? So that data is converted to a points. So that means there is some algorithm by using that particular data is converted to a point. Okay, and then on that particular point, right? So on that particular point now some you can say that some algorithm is applied, and with the help of that key, with the help of some key, now that points now it is converted, now that it is converted. Okay, now it is encrypted. So in this way the working is done. So later I will explain you how the encryption and decryption is done. So now today what I will explain you. So whatever the data is given to you, okay. So now see how to find the point. So today I will explain the point generation part. Okay. So how to generate the points in a ECC, because that will be very useful part for encryption and decryption. Okay. So now listen here. Assume that this equation, all of you know that for elliptic curve vector system data of this form y square that is equals to x cube plus ax plus b, this type of form is there, right? So EPAB that is equals to x cube plus ax plus b more p. So where p is the prime number and a and b are the parameter. Now let's say, see here if I am writing the p, the value of p prime number that is 30, okay, and 1 1 that this two parameter that I am passing. Okay, a and b, the value of a is 1 and the value of b is 1. So now what happened? So here it implies that instead of that can I write x cube plus x plus 1 more 13 that is equals to y square. Right, so that's why I can say that the y square equals to x cube plus x plus 1 more 13. Okay, so now this type of equation is there, right? Now from that, now I want to find the I want to generate the point, right? So one by one, the different value of, you have to start from 0. Okay, so here let's say I put x equals to 0. Okay, so when I put x equals to 0, so what I get, y square, that is equals to I am getting 1. Okay, so 1 more 13, but it's a square, so that's why, what is the square root? So y equals to plus 1 and minus 1. So these are the two possibilities that you are getting, and all of you know that the minus 1 more 13, so that's why in cryptography, what you have to do, if it's a negative, then you have to add the plus 13. So that's why the two root that I am getting when x is 0, so at that time 2y value I am getting, that is, one is 1 and another is 12, and that's why the 2 points over a what, E311, so that means over this elliptic curve. So see, this is the equation of elliptic curve, everyone. So now first of all, you have to find the points or which are the point for a particular value of x, what you are getting is the point for y. So that you have to find, right? So here what I am doing, first of all, I am taking x equals to 0. So for this x equals to 0, I am getting the two values of y, right? So that's why I can say that one point, that is 0, 1, and another is a 0, 12. These are the 2 points over E311. Up to this clear, everyone? Is it clear to you all? Hello? Can you hear me? Okay, so up to this clear, everyone? Okay. So one by one, you have to take all the values of x. So first of all, x equals to 0, that I have put. Now next, x equals to 1. So when you put the x equals to 1 in this equation, so what you get, 1 cube plus 1 plus 1. So what you get, y square equals to 3 more 13, right? So here in this case, what happened? The square root of 1 is possible. So that is plus 1 and minus 1. So from that, we can identify for x equals to 0, either we are getting 1 or 12. Okay, so these two points that you are getting. So now y square equals to 3 more 13. So in this case, what happened? The square root of 3 is possible? No. So that's why what you have to do. So first of all, you have to check whether, if you want to find the points. Okay. So first of all, you have to check the 3 is a quadratic residue with respect to mode 13 or not. So now the question arises in your mind, that is how to check for quadratic residue. So first of all, I will explain you what is quadratic residue. So now see here, so you can understand. Now see, just you have to remember the quadratic congruence, the equation of this type of form, a2x square plus a1x plus a0, that is congruence 0 mode n. We will limit our discussion to what here in this case you have to assume a2 equals to 1 that I am taking, and a1 equals to 0 that I am taking, right? So here what it becomes, x square plus a0 congruence 0 mode n, or you can write in this way, x square, it is congruent to minus a0 mode n. Now let's say minus a0 mode n, so that I am considering it as a, right? That you have to consider that thing. So now what you get, x square, that is congruent to a mode n. Now we are working on this thing. So now listen here, this type of form is there, y square equals to 3 mode 13. Is this type of form is there, everyone, right? X square congruence a mode n. So now what is our question? Our question is, if this type of form is there, then how to find, how to check whether the particular a, let's say here a. So how can I check that, whether it's a quadratic residue or not? Okay. So now what you have to check? So here first understand the theory. So here you can say that you have to find the solution for an equation of this form, x square congruent a mod p, where p is a prime and a is an integer such that p does not divide a. So this is the sign for that the P doesn't divide A. So this type of equation has either a no solution or exactly the two incongruent solution, right? So if this type of form is there, see basically what is our purpose? So here y square equals to 3 more 13 is there, right? So the square root is not possible. So if the square root is not possible, then first of all you have to check whether it's a quadratic residue with respect to more 13 or not. Now how to check for quadratic residue? How to get the points? If it's a quadratic residue, then we can generate the point. So for that, which is what is the condition? So see, it's a similar equation, right? So if this type of equation is there, so this type of equation has either a no solution, or you can say that exactly the two incongruent solution. Exactly the two incongruent solution, right? So here you can say that see the x square, let's see the x square congruent 3 more 11, right? So now see all of you know that the one of the approach, that is brute force approach. So in brute force approach, what you have to do, you have to put the different value of x, right? Now, so if I put 0, 1, 2, 3, one by one, is how to put the different value of x, right? So now all of you know that when the x equals to plus 5 or minus 5. So now see, if I say x is 5, so 5 square is 25, 25 more 11, that means what you get? 2. All of you know that what is the meaning of congruence? What is the meaning of congruence? Can anyone explain me? X square congruence, x square congruence 3 more 11. What is the meaning of it? Please write down in chat window, everyone. Please write down in chat window. Can you hear me, everyone? Yes, yes, you are correct. So when you perform the x square mode n, that is equals to a mode n. Yes, you are correct. So now here what I am doing, now I am using the brute force approach. Different value of x I am putting, and you know that when the value of x is 5, right? So at that time what happened? It's a 5 square. 5 square means 25, and 25 mode 11. So that means what you get 3. So that means you can say that both the side you are getting the same value, and that's why here you are getting, why I am writing the two incongruent solutions. Can anyone tell me? Plus 5 and minus 5, that is 6. So is it a incongruent solution? 5 and 6 are incongruent? Yes or no, everyone? So that means you can say that. So see here one point that I have written, that is if this type of form is there, this type of equation has either a no solution or exactly the two incongruent solution that you are getting, right? So here I can say that one is a 5 and another is a 6. So these are the two incongruent solution that I am getting. Now see here directly I know the answer, that's why I have written directly. Now here in this case the same brute force approach that I told you that I have written. So what I am doing here, if I want to check here whether the solutions are, I want to check whether this type of equation has a solution or not, that I want to check. So what I am doing here, initially from x equals to 0, I will start here. So when it is 0 square, so I am getting 0 mod 11, 0, 1 square means 1 mod 11, 1, 2 square means 4 mod 11, 4. In this way you have to do it. But after this step, what happened? So now see, in any of the case, are you getting 2? Got it what I'm trying to say, everyone? In any of the cases, you are, but because after the 11, the values are repeated. So in any of the cases, I'm not getting this 2. And that's why I can say that no solution. Yes or no? Yes, yes, Priyank, you are correct. No, not getting the two incongruent, and that's why you can say that you are not getting any solution. Up to this clear, everyone? Is it clear to you all? Which part I will repeat, Priyank? Priyank, can you unmute yourself? Hello.
Ma'am, that two congruent one.
See here what I have done here, Priyank. So basically, you know the what do you mean by congruent? Congruent means when I put the different value of x and when I perform the mode 11, so I am getting this. See what is the meaning of? So the meaning of this congruence, that is x square mode 11, that is equals to 2 mode 11. 2 mode 11 means 2. Yes or no?
Yes, ma'am.
Right. So if I put the different value of x, so in any of the case I am getting two answer.
No.
Got it? What I'm trying to say? The if the LHS that is equals to RHS. In our case, congruence means the meaning is the x square mode 11. Whatever x square mode 11 means, if I put x as a zero, so I get zero. If I put x as a one, then once one, then I get one. So for different value of x, in any of the case, I am not getting this right hand side answer two, because the two mode 11 is true. The meaning of congruence is x square mod 11, that is equals to 2 mod 11. Now is it clear?
Yes, ma'am.
Right. So in any of the case I am not getting 2. That's why I can say that has no solution. Now clear?
Yes,
Here
ma'am.
what happened? Here in this case, see, starting from the zero value, first I put 0, 1, 2, 3, 4. One by one I am putting all the value. But when I put, because I know the answer, that's why directly I have not used this approach. So when I put x equals to 5, so at that time what you get, Priyank? 5 square, that is 25. 25 more 11, that means what you get, 3. So you are getting the same as RHS. Now clear, Priyank?
Yes, ma'am.
And that's why plus 5 and minus 5. So that means and all you know that minus 5, if it's a negative, then you have to add the more. So minus 5 plus 11, so what you get, 6. Now clear?
Yes, ma'am.
Okay. Now see, this is the one way, that is a brute force approach. Okay. So if this type of equation, that means, see, the purpose of what? If this type of equation is there, see here in our case what happened? Here you are not, here in this case directly I can say that these are the 2 points, because the square root of 1 is possible. But when the square root is not possible, then what happened? You have to check whether it's a quadratic residue or not. Okay, so now for that, these are one way. What you have to do? So first of all, you have to find by first means by using the brute force approach, you can say that. Okay. Now another way is, but see this method brute force approach is very difficult when the p means the value of p here right now it's only 11 is there. So then the brute force approach is good. But if this p value, the prime number value, if it's very large, then it's very difficult to use this brute force approach, to apply the brute force approach. Is it clear, everyone? And that's why, see, you have to apply this rule, and based on that, you can say that you can say that it's a quadratic residue or not. So now see here, in the equation x square congruent a mod p. So this type of form is there. So here, when you can say that a is called a quadratic residue in our case, when you can say it is this type of form. So when you can say that this 3 is a quadratic residue, so for that, what you have to do? So read here, in the equation x square congruent a mod p, the a is called a quadratic residue if the equation has two solutions. Okay, and a is a quadratic non-residue if the equation has no solution. Okay, if the equation has no solution, then you can say that the a is a quadratic non-residue. And in ZP star, exactly, the p minus 1 by 2 elements are quadratic, and p minus 1 by 2, that is a quadratic non-residue. So when you observe here, so when you observe here in Z11 star, right, Z11 star means you can write it this way, 1, 2, 3 up to 10. Okay. So here these elements are quadratic residue. Why? Because see here when you can say that has a solution with respect to mode 11, and these are the point where there is no solution. Now see, observe here, for which value you are getting 1. Can anyone tell me? Where you can say that x square is congruent 1? Please reply so I can understand. See, starting from the, if you are using the brute force approach, so starting from x equals to 0, right? Now I put the x equals to 1. So when I put x equals to 1, what I get? 1 mod 11 means what? You're getting the same as RHS? Yes or no, everyone? Is it clear up to this? Please reply so you can understand everyone. Hello? Is it clear to you all? Hello? Please reply so I can understand. So in all these case, right, I can say that it has a solution with respect to mode 11. Okay, so see, same way here you can say that when you can say that x square congruent 3, that already that I have explained, right? Different value of x I am putting. So for for the value of 5, I am getting these 3. That means here I can say that for each and every case I am getting the has a solution with respect to mode 11, and these are the cases where it has no solution with respect to mode 11, right? So the same case that I have explained, right? And that's why I can say that in ZP star, exactly, the p minus 1 by 2 elements are quadratic residue, and p minus 1 by 2 are quadratic non-residue. Okay, and this point that you have to keep in mind, in the equation, A is called the quadratic residue if the equation has a solution. And if the equation has no solution, then you can say that it's a quadratic non-residue. Okay, so there's 2 points that you have to remember. Now, these are the two criteria that you have to remember. That is to check if the integer is a quadratic residue modulo p or not. So for that, this formula that you have to use, that is, if a raised to p minus 1 by 2, that is congruent to 1 mod p, then a is a quadratic residue mod p. And if a raised to p minus 1 by 2, that is congruent minus 1 mod p, then you can say that the a is a quadratic non-residue. Now, if you want to check whether the 2 is a quadratic non-residue with respect to 11, so for that you have to use this formula. So now what you have to do, so here in this case a is 2, the p is 11. So now what is the equation? A raised to p minus 1 by 2. So a raised to p minus 1 by 2, the value of a is 2, 2 raised to, what is pp, that is 11, 11 minus 1 by 2, so what you get? 5. So 2 raised to 5 more 11, so what you get? 10, and instead of 10, can I write minus 1 more 11, right? And see, so now read this. If a raised to p minus 1 by 2, that you are getting minus 1, that means you can say that it's a quadratic non-residue. That means it has no solution. So up to this clear, everyone? Priyank, so in which part you are not getting? Please unmute yourself, Priyank.
Quadratic residue and
So where you are not getting? See, are you getting this thing?
yes, ma'am.
Right? So here you are getting the solution. In this case, you are not getting the solution. Up to
Yes,
this
ma'am.
point, you are clear?
Yes, ma'am.
Right? So quadratic residue means if you get the solution, then it's a quadratic residue. And if you are
Okay.
not getting the solution, then it's a quadratic non-residue.
Okay.
Right? But now you want to see, this is a theoretical part. But if you want to check by using this equation, so this is an easy method. So how to check for whether you are getting the quadratic residue or not? So what you have to do, you have to apply this method a raised to p minus 2 congruent 1 mod p. So you have to calculate this a raised to p minus 2. If you are getting the one answer, then you can say that it's a quadratic residue. And if you are getting the minus one answer, then you can say that it's a quadratic non-residue. And what is the meaning of quadratic non-residue? The quadratic non-residue means the equation has no solution. And the quadratic residue means the equation has a solution. Up to this clear?
Yes, ma'am.
Right, now see, check here. Here the value of a is 2 given and the value of p is 11. So now you have to use this formula a raised to p minus 1 by 2, right? So what is the value of a? A, that is 2, p is what? 11. So what you get the answer? 10. So instead of 10, can I write it this way? Minus 1 mod 11. Up to this
Yes,
clear,
ma'am.
Priyank? Right?
Yes, ma'am.
So here when I using this formula, so I am not getting 1, I am getting what? Minus 1. So minus 1 means it's a quadratic non-residue.
Yes, ma'am.
Now clear? And if it's a quadratic residue, so see quadratic non-residue, then what I have written, it has no solution. Clear up to this, Priyank?
Yes, ma'am.
Right. So now see the second example, you can see so you can understand. So now again I am taking A as a 5 and P is 11. Okay. So now in this case I am using this formula A raised to P minus 1 by 2. A is 5, P minus 1. So what I'm getting 5 raised to 5. So all of you know that instead of that, can I write 5 square multiply by 5 square multiply by, because the power, you have to do the addition of power. Yes or no?
Yes, ma'am.
Right. So what you get the answer 1. What you get the answer 1. So now here you can say that here you are getting 1. And that's why here I can say that it has a solution. If it is 1, that means it's a quadratic residue. Yes or no? And if it's a quadratic residue, means it has a solution. Up to this clear?
Yes, ma'am.
Right. Now see here. Here I have written here because I know that, sorry, here the directly that I have written the two roots, because the two root that is 4 and minus 4, that is the answer. But now the question is your mind, that is if it's a quadratic residue, then how to find the solution? So again I repeat everyone. See in this case what I have do. So suppose I want to see this type of equation is given to you. You want to generate the points. So for that, first of all, see the square root of 1 is possible. That's why directly I have written there are two answers plus 1 and minus 1. Now here the value of here it is 3. The square root is not possible. So now you have to check whether it's a quadratic residue or not. So if for that what you have to do, so you have to use this equation A raised to P minus 1 by 2. If you are getting 1, so it means that if you are getting this one, that means that means you can say that it has a solution, right? You don't know which solution is there, but it has a solution. But if you are using this formula and if you are getting minus 1, then you can say that it is a quadratic non-residue, means the solution is not possible. Right now the question is your mind, that is if it is 1 in our case, if it is 1, then how to get the solution, right? So for that what you have to do, these are the cases that you have to remember. Okay, so right now here I have not written that cases, but see I will explain you so you can understand. Okay, so for that in this PDF I have written what you have to do. So see here. Up to this clear everyone? How to check whether it's a quadratic residue or non-quadratic residue? I think all are clear. Right now see this PDF. So now in this particular case, I want to check whether it's a quadratic residue or not. So what I have to do? So all of you know that according to this formula, A is a quadratic residue with respect to mode P. If you have to use this formula, that is A raised to P minus 1 by 2 mode P, that is equals to 1. So now what I'm doing here, so if it is a quadratic residue, then the solution is possible. If it's a not a quadratic, it's a quadratic non-residue, then the solution is not possible. These are the two cases. All of you know that. Now what I'm doing here, I'm using this formula, right? So what is the value of A? So A raised to P minus 1 by 2 mod P, that I am using. What is the value of A? A, that is 3. Okay, and what is P? The value of P, that is prime, that is 13. So what I'm doing here, 3 raised to 13 minus 1 by 2 more 13. So what I'm getting here, 1. So now here in this equation, I'm getting 1, and that's why I can say that the solution is possible, right? It's a quadratic non-residue and it has a solution. So now the question arises, that is how to get the solution. So now you have to apply this rule. So based on that, you have to find the, and based on that you have to get the solution. So now see here, what is the rule? So if A is not a perfect square, right? So then add P to add P to A and check the new value. That is the A plus P is a perfect square or not. Again you have to check. If A plus P is not a perfect square, then again you have to add P and get A plus 2P. repeat this process till a plus kp that is less than equals to p square. Now see this, so you can understand y square equals to 3 more 13. So 3 is not a perfect square because the square root is not possible, right? So you can say that it's not a perfect square. Now if it's not a perfect square, then what you have to do? See this rule. If it's not a perfect square, then add p, means whatever the prime number is there, it is added to a. So now what you have to do? It's not a perfect square. So you have to add this 13 to 3. So what you get? 13 plus 3, that is 16. So now all of you know that y square equals to 16 more. Just wait everyone. So here in this case, the 3 is not a perfect square. So what you have to do? Add 13 to 3, right? So what you get? 16. So the square root is possible. So here you can say that it's a perfect square. And if it's a perfect square, then all of you know which are the two solutions are there. That is y equals to plus 4 and y equals to minus 4. Right? And if it's a minus 4, then all of you know that you have to add this 13. So that means you can say that the two solutions that you are getting when the x is what? So the two solutions that you are getting, that is when the x equals to what? When x equals to 1. When x equals to 1. So at that time the 2 points that you are getting, that is what? 4 and 9. So that means one is the 1 4 and another is the 1 9. These are the 2 points on this curve. So up to this clear everyone how to get the point? Any doubt? Please reply. Hello. Is it clear to you all? Right? So this thing that you have to remember everyone. So now next I will explain you the other so you can understand. So always you have to remember, if this type of equation is given to you, you want to find generate the points on a curve, then what you have to do? So first of all you have to check whether the square roots are possible or not. So directly here I am writing plus 1 and minus 1. But see here in this case the square roots are not possible. So first of all you have to check whether the 3 is a quadratic residue or not. So if you want to check whether it's a quadratic residue or not, so for that what you have to do? So first of all you have to use this formula, that is a raised to p minus 1 by 2 more p. Okay, so now once you are using this formula and if you are getting 1, so in our case we are getting 1. So that means you can say that it's a quadratic residue and the solutions are possible, right? So in this way you have to check whether it's a quadratic residue or not. And if you are getting minus 1, that means it's a quadratic non-residue, means no solution. Now, once you understand that it's a quadratic residue and the solutions are possible, so now the next task is how to generate the points, how to find these 2 points. So for that, what you have to do? So first of all, you have to check whether it's a perfect square or not. If it's not a perfect square, then what you have to do? You whatever the value of prime number, you have to add this p to a, and whatever the new value that you are getting, that you have to check whether it's a perfect square or not. And again, if you are not getting the perfect square, again you have to add this 13 to 16. You have to continue to repeat this process until the a plus kp that is less than equals to p square. So in this way, you have to continue doing it. Right, and that's why finally you are getting these two solutions. So that's why, see here in this case directly I have written the answer, that is a equals to 4 and minus 4. So by using this we are getting these two solutions. So up to this clear everyone? Is there any doubt? Can I explain you the next one? Hello, can you hear me? Hello, hello. Okay. Now see, in the same equation, see, first of all, I have started from x equals to 0. So for x equals to 0, I am getting these 2 points on a curve. For x equals to 1, I am getting this 2 point. Now I'm putting the x equals to 2 value. So in which equation you have to put? So you have to remember this equation. So that is because here the value of a that I have taken 1, the value of b that I have taken 1. So that's why, see, in exam also I will explain you this type of point generation. This type of question can also be asked. So this type of equation is given to you. So where I have used, let's say a is a1 and b is 1. So now the equation becomes like this: a3 x cube plus x plus 1. So in this equation, one by one, you have to put the different value of x. So first I am putting x0, then x1. Priyank, the points are 1 and 4, because for which value of x you are getting. So when the value of x is 1, see here, when value of x is 1, so at that time you are getting the value, the two values of y. Now clear, Priyank? So see, when you draw any graph or something, so when you can say the two coordinates that you are getting, that is x and y. When x is y1, at that time you are getting which value of y, that is 4. When x is 1, so at that time which value of y you are getting, that is 9. Now see this graph here. So here you can say that when y is 0, the 2 points. So I can say that x is 0, y 0 is this point. X is 2 and y is x is 2 and y is 0 is this point. X is minus 2 and y is 0 is this point. Now is it clear, Priyank? Right? Now next what you have to do? See, listen. So now you have to take x equals to 2. So in this equation I am putting the value. See here, y square equals to x cube plus x plus 1, right? Because a is 1 and b is 1. This type of equation is given to you. So you have to remember this equation. In this equation, so the value of a and b that you have to put. So this equation that you are getting, that is y square equals to x cube plus x plus 1. And one by one different value of x that you have to put. So 0 that I have put, 1 that I have put, now I am putting x equals to 2. So what I am getting, y square equals to 2 cube plus 2 plus 1 more 13, right? So this equation that I am getting, right? So now what which value that you are getting, y square equals to 11. Now see here, all of you know that for 11 the square roots are not possible. So now what you have to check next, please write down in the chat window, everyone, if the square roots are not possible. So now next what you have to check, please write down in the chat window. No, and not p. You have to check for what? Quadratic residue. Now see here. Here in this equation, y square equals to 11 more p. These are this type of equation. Now see for 11, can you directly write down the solution? Because for 11 the square roots are not possible, right? If instead of 11, if I am writing 1, then the two solutions are possible, plus 1 and minus 1. But for 11 the square roots are not possible. So what you have to check, you have to check whether the 11 is a quadratic residue or not. Now how to check for 11 it's a quadratic residue? So you have to use this equation, e raised to p minus 1 by 2. So when you use this equation, I am getting minus 1. And all of you know that rule. See this rule. If it's a minus 1, then it's a quadratic non-residue. And if it's a quadratic non-residue, that means I can say that for x equals to 2, I'm not getting any solution. I'm not getting any points on a curve. Is it clear, everyone? Hello? Is it clear? Please reply. Okay. Now, so that's why I can say that there is no solution. Now, next I am putting x equals to 3 in this equation. So here what I am getting, y square equals to what I'm getting, y square equals to 5 more 13. So again the square roots are not possible. So again I have to check whether the 5 is a quadratic residue or not. So what I'm doing here, I'm using this formula, a raised to p minus 1 by 2. I'm using this. So again I am getting the minus 1 answer. So that's why I can say that there is no solution, because it's a quadratic non-residue. So the solution is not possible. Now again I am putting x equals to 4. Okay, so now again I am putting x equals to 4. So here I am getting 4. And see, directly here I can say that it's a perfect square. So directly I am getting the answer y equals to 2 and y equals to minus 2. So that's why when x is 4, I am getting the 2 points, 4, 2 and 4, 11, because it's a negative. So I am adding this 13. Up to this clear? X equals to 4. Is it clear to you all? Please reply. Okay. So now I am putting x equals to 5. So in this equation, when I'm, so see, this point generation is asked in exam, right? The equation is given to you. Okay, you have to generate the different points. Okay, so this type of question can be asked. So y square equals to 5 cube plus 5 plus 1. So what I'm doing here, so here I am getting 1. So directly I can say that for 1 I am getting the answer. See, when to check for quadratic non-residue? So if this type of possibilities are there, here 5 is there, so the square root is not possible. So now then if it's not a perfect square, then you have to check for check whether it's a quadratic residue or quadratic non-residue, right? But here in this case, directly I am getting the answer. It's a perfect square, so I am getting the answer plus 1 and minus 1, right? So these are the 2 points when x equals to 5. At that time, I am getting these 2 points. Now after that, you have to use x equals to 6. So now see here, now observe here. So again I am using this formula. So now again what happened? It's a 11. So 11 is, it's not a perfect square. So what I am doing, I am using this formula a raised to p minus 1 by 2. But here in this case I am getting 12. And instead of 12, can I write minus 1 more 30? So that's why I can say that there is no solution for x equals to 6. Because for some of the points, you are not, for some of the value of x, I am not getting the points, right, on a curve. Now, again, I am using x equals to 7. So, if the value is 0, then all of you know that the 7, 0 is a point on a curve. And again, check for x equals to 8, everyone. Okay. So, now please everyone check for x equals to 8 and please reply. Okay, now see, directly I will show x equals to 8. What do you get? You get 1, and all of you know that the roots are possible, plus 1 and minus 1. Right, now everyone check for x equals to 9 and please reply me. Please reply me in chat window in this equation. Put the value of x as a 9, okay, and give me the answer. Quickly, I will give you a time. Please reply. So what's the answer? Please reply me. Hello, can you hear me? So please reply everyone. Put the value of x equals to 9 and give me the answer. What do you get the answer? In this equation, you have to put the value in this particular equation. So what you get the value, Priyank? Hello. Which value you are getting? So now see here. In this particular equation, if I put x equals to 9, right? So what you get, y square equals to 9 cube plus 9 plus 1. Okay. So what you get here, 11. So for this value 11, it's not a perfect square. So what you have to check for quadratic residue. And all of already that we have checked for this 11. So in this particular case, it's a quadratic non-residue, and that's why you can say that there is no solution. Okay. Now check for 10 everyone and reply me. Is the solution is possible or not? Please write down in chat window. Dev, no solution for which value of x? For which value of x you are seeing? X equals to 9. Okay. Now check for x equals to 10 everyone and please reply me. So it's a practice for you. Please everyone do it in your notebook. What's the answer? Okay, Priyank, there is no solution for x equals to 10. Okay, so let me check. So here, what you get? Here you are getting 10, and that's why what I'm getting. Okay, but Priyank, here in this case, what happened? When I put x equals to 10, okay, so here you are getting y square equals to 10 more 13. So now it's not a perfect square. So what I'm using, so first of all, you have to check whether it's a quadratic residue or not. So if you want to check for quadratic residue, then all of you know that which formula that you have to use, a raised to p minus 1 by 2. So if you are using this formula a raised to p minus 1 by 2, so here in this case I am getting 1. So if you are getting you 1, so that means it's a quadratic residue. The 10 is a quadratic residue. And if it's a quadratic residue, then the points are possible. Okay. So now how to check, how to get this point? So first of all, what you have to do? So the y square equals to 10. So it's not a perfect square. So that's why what you have to do? So you have to add p. P means what is the value of p? P that is 13. So 13 plus 10, what you get? 23. So again, you are getting the 23 means again it's not a perfect square. So again, what you have to do? Again, you have to add p to this value. So now I am getting 36, right? And that's why here again, so 36 is a perfect square, and that's why the two solutions that you are getting, that is y equals to plus 6 and y equals to minus 6. So up to this clear, everyone? Yes, Prince, the solution is possible for x equals to 10. So now is it clear? Anyone have a doubt? Hello? Can you hear me? Prince, Priyank, Dev, is it clear? Right? Okay. Now what about x equals to 11? Please check and reply me. For x equals to 11, the solution is possible or not? So quickly do it and reply me. So is it possible? Hello? Is it possible, everyone? Okay, Prince, is it possible, right? If it's possible, then what's the solution? What's the solution? Abhi, 2 and minus 2. So let me check. So, okay, so here you are getting 4. That means the two solutions are there, 2 and minus 2. Okay. So now let's check for x equals to 12, everyone, and reply me. It's a practice for you, so you can understand. So for x equals to 12, the solution is possible or not? So please check and reply me. Okay. Okay, so see here, for x equals to 12, when I'm putting this value, so what I'm getting here, y square equals to 12 more 30. So now here you can say that it's not a perfect square. If it's not a perfect square, what you have to do? You have to use this formula a raised to p minus 1 by 2. So now when I'm using this formula, so by using that I am getting 1. And if I am getting 1, that means you can say that it's a quadratic residue and it has a solution. Okay, so now it has a solution. Now when you are finding this solution, so now I am checking here. Okay, it's a 12, so it's not a perfect square. So what I have to do? I have to add this p to this 12. So now when I'm adding 12 plus 13, so what I'm getting 25. So now it's a perfect square. So now see, in previous to previous example, this thing that I have done. So here I am getting 23, but again it's not a perfect square. So what I am doing here, again I am adding this p to this 23. So and then after you have to check whether it's a perfect square or not. So but in this case what happened? The 12 is not a perfect square, so I am adding this 13 to this 12. So I am getting 25. So now you have to check whether it's a perfect square or not. So now here it's a perfect square, and that's why I am getting the two solution plus 5 and minus 5. And if it's a negative sign, then all of you know that you have to add this 13. So now finally the two solutions where x is 12. So the two solutions that I am getting 12 5 and 12 8, right? So there is an algorithm regarding this the finding the points on an elliptic curve. So all of you know that initially the x is 0 while x is less than p. What you have to do? So you are using this equation. Now every time you are what you are checking. So checking for quadratic residue, you are using this formula w raised to p minus 1 by 2 mod p. If it is equals to 1, then you can say that there are a solution. So these two solutions that you are getting and you have to return it. And the another is that is if it is equals to minus 1, then you print there is a no solution for this. Okay, and continue you are incrementing the value of x, and every time see you have started from x equals to 0, then 1, then 2. So continue, you have to start from 0, continue how to repeat this process, right? And based on that you have to check whether it's a QR or not. If it's a QR, the solution is possible. If it's not a QN, if it's a QNR means quadratic non-residue, then there is a no solution. So up to this clear everyone? If any equation is given to you, how to find the points on a curve? Is it clear everyone? Is there any doubt? Okay, thank you everyone. I'm ending my session.